Today we're going to be talking about graphing higher order polynomials. And so one thing to note when we do this, we have to remember what's the point of all this? And well, that is everything has a shape. We've had our v-shaped graphs, so we have y is equal to the absolute value of x, and that makes a v-shaped graph, right? Then we have y equals x squared, and that makes a u-shaped graph. So what shape graphs do these make, and is there a uniqueness or difference? So we'll just talk about that, and they call it end behavior. That's what they call it. So let's take our first one here, y is equal to 2x cubed. So let's put this into Desmos. So let's see here. Just going to move this up a little bit so you can see. I'm going to paste this in if I can. I don't think it's going to let me, so let's type it in. So y is equal to, where's the power button? There it is. Oops, we got to go back. That x square or cubed rather. Okay, let's look and see what we got. So if I zoom in a little bit, we can see that this graph looks like that. Okay, so let's go back to our notes. Let's add that in there. So this here looks something like this. Okay, a lot of my students like to call it a noodle. The correct term is called a cubic. Okay, notice that this is positive, right? Which means that if it becomes negative, it flips upside down. I'll talk about that in a minute. So this is called end behavior. So on the left side, it's down. So notice over here, it's down. And over here, it's up. And in mathematics, we have a weird way of writing this. So it says as x is going left, right? So this means x is going left because negative infinity on x is left. Then y, again f of x just means y, is going down. Just remember negative on y is down. So that's how we talk about this downside on the left side here. Up here, it's on the right side is up, and so when x is going right, so we use a positive infinity, then y is going up. Now we don't write up, we write positive infinity. And that's how we do it mathematically. So there's two ways to understand it. Right side's up, left side's down on our cubic, or where the arrows are going, and then, or we could write it out mathematically. Now this one here, this next one here is the same exact thing. So I'm going to take a little extra space here. But there's a negative here now. That's called a leading coefficient. So this right here is just going to be the same thing, but switched around. And so we're going to do the same process because this is down and this is up. So when x goes left, y goes up. So that's positive infinity. So just remember that we're doing the same thing. Left is up, right is down. So to say right mathematically, so if I'm telling people I'm going right mathematically, I go x with an arrow and it goes to positive infinity. Then that means that our y is going down with negative infinity. It's a little weird notation writing, but it follows, it should make sense because negative on x is left, positive on x is right, negative on y is down, positive on y is up. So let's look at this one here. Let's put that one into the graph. So let's delete this out here. So, delete this, put it with a 4, delete the 2. Okay, so notice this one. It looks like a U shape, but it's a little different. And it turns out, if we zoom in a little bit, it'll still look like a U shape here. But if we add extra numbers in there, it actually can turn into a W, which is kind of a little different here. So if I add some extra stuff here, plus x, just that. You can start to see this little w or v. There's a v, almost a v, but still more like a u. Squared. And let's subtract this. Let's delete this and put a minus in there. There we go. There's our w. So notice that it can be a w as well. So this power of 4. Let's go back to our notes. So notice this is odd. So all odds will follow this procedure, but we're not going to go too big. Power 5 or power 7, we're not going to really do much. We're just going to do powers of 3. Powers of 4 and higher that are even. So here we have even, and this is positive in front, are going to look like u's or w's. So they're going to look something like this. And I always like to put a little squiggly in the middle just to show you that these x to the fourths may have squigglies in the middle, but that's what they're always going to end up pointing both up. And so notice that's what we're really trying to focus in on here, is the need for these to both point up. So on the left side, so as x is going left, y is going up. And then on the right side, over here, x is going right. That means y is going up. So that's how you write it mathematically. Left side up, right side up, and then this literally means left side up. This literally means right side up. They're talking about where those arrows are going, because that's once we know where all the squigglies are in the middle, then you just draw the arrows. Okay, and then this is going to be no difference. If we put this in Desmos, it's just going to be like a U like that. But if I add an extra couple numbers, we will get a W shape. So I always like to write a W shape just because that's going to be more common when we deal with these. And again, it's always when we have an even largest power. Now it's negative in front, so that's why we're getting both downs. So on the left side it's going down, on the right side it's going down. So how we'd write this as x is going to the left, y is going down. As x is going right, y is going down. Okay, now how I'd read this would be as x approaches positive infinity, f of x approaches negative infinity. But really what we're saying is x is going left, so on the left side, y is going down. And you see that with the arrow. So here we have a question. Which graph below could be the graph of y is equal to negative 3x to the fourth plus 9x squared plus 4? So all this information tells us some things. If it's, so I'm going to highlight this, if it's an odd power, we're looking at noodles or cubics. If it's an even power, we're looking at u's and w's. Okay? So if I take my highest power here, which is a 4, it's always the largest power, that already tells me that it should be a w or a u. So that means that this is gone and this is gone. Now if I look at the number in front, this negative here, the negative tells me it's supposed to point down. Or in other words, as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity. That's a mathematical way of saying it, but what I'm really saying, on the left side it's down, on the right side it's down. So that means this is my only possible answer. So notice we could take something that looks very hard and easily find a multiple choice for it by understanding what numbers do. Lastly, we're going to graph this. So to graph these on our worksheet today, we're just going to pick points. I'm going to pick, let's pick -2, let's pick 0, let's pick 1, and then we can pick 3 here. And then we're going to plot our points in graphs. So we're going to graph these. So to do this, we're going to put these in to our problem here. So I just substituted them in. Then we're going to use our powers first. So 2 times 2 times 2 is -8 there. -2 squared is 4 plus -2. 3 times -2 minus 4. Then we're going to multiply. And then we're going to find an answer here. So that's 10, -30, -46. And that's going to go right there. and then 0 is negative 4. When I put a 1 in, so I put 1 in for everything, so we're going to get 2, 1 cubed, minus 5, 1 squared, plus 3 times 1 minus 4. And then this is kind of simple because 1 times 1 times 1 times 2 is 2, 5, 3 minus 4. So it goes pretty quick. So it's negative 3 plus 3 minus 4. So the answer is just minus 4. And then we're going to put a 3 in and do the same. So again, I'm going to put a 3 in. So we have 2, 3 to the third minus 5, 3 squared plus 3 times 3 minus 4. Make sure I write this out right. Is that positive? Positive, yeah. So 3 times 3 is 9, times 3 is 27, and times 2 is 52. 3 times 3 is 9, minus times 5 is 45. 3 times 3 is 9, minus 4. Then we just solve it out. So we have 7 plus 9 minus 4, so that's going to be 12. Then we put it here. Now, again, this is really easy in the calculator, like super easy. You just type in and hit enter. So if you're having trouble with all this stuff, seriously, just borrow a calculator of mine and just type in and hit enter. So you have negative 2, negative 46. I'm just calling negative 46 down here. And then we have 0, negative 4. Then we have 1, negative 4. 1, negative 4. And then we have 3, which is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there. So we just have 3 dots, kind of like, or 4 dots everywhere. It doesn't even make sense. But we have to remember that this shape is going to look like that. No, not that one. I apologize. It's a power of 3. It's an odd, and it's positive. So I apologize. That means it's going to look like this one. So again, if we go back to the beginning, this is the one it's going to look like. It's going to look like this little cubic there. So when I draw my graph through all these points, I'm going to make it look like that. Okay? And then you can always check your answer. Go plug it into Desmos. Now this isn't the best way of graphing, but it gets the job done. And later on, we're going to learn a more efficient way of graphing. But this is good. So again, just to recap, based on what we're given, if we're given a odd, it's going to look like this noodle thing. If we're given an even, it's going to be U or W. Okay? And then negative down, negative down. And then we can use that to match up stuff. And then we can go back through and plug points in, which gives us kind of random dots. But then when we know the shape, we draw the correct shape. So I drew this shape right here. Okay? If you have any questions, let me know. Have a great day.